Alright guys, so here we have to figure out how far to the right of the center of the circle does the ball hit the ground. So if the ball is going to go obviously here to the right, we have at the center of the circle is 510 above the floor, and the ball itself is 3 kilograms. It's tied to the 50 centimeter long string, which is the radius. So what we do is we find the minimum speed achieved when time equals 0. We do mass times gravity equals mv squared over radius, right? So we do b equals to 50 to be equal to 0.5 meters. So 0.5 times 10. Velocity is equal to 2.21. So the distance, we're gonna have to find the vertical component when at the top of the ball releases. So in order to do that, we find the equation of motion to find the time it taken to reach the ground. So equation of motion, t over 2, 510 plus 50 is 560 centimeters. You turn it into meters, equals 5.6 meters. And as before, we'll find the vertical component at the top. The gravity times time squared over 2, time equals 1.069 seconds. So then the horizontal component remains constant. The distance we find is velocity times time. The distance equals 2.21 times 1.069 equals 2.36, which is 236 centimeters. So the closest to that is 240. Okay, so here we have 90 milligram speed on a 60 centimeter long swing. So we have to find how far to the right, to the center of the circle that the ball hit the floor. So we have to find how much to the right, to the right. So we find that the tension of the string is 2.2, very bottom. When this is at the very bottom, right? 2.2, that's the tension. So because we have the tension is 2.2 and the radius, we find it to be, is 60 centimeters, which is 0.6 meters. So first we must find force is the tension minus mass equals times mass times gravity. So here we are finding acceleration, which is mxv squared over r t minus mass gravity. So we have this eventually, right? Which is given us 0.6 meters, 2.2 newtons minus 0.9 newtons over 0.09, because obviously that is what it was, from grams to kilograms. It's 0.9 kilograms, right? And this 0.9 newtons is given by work mass times gravity is 0.10, this is 0.9 newtons, 0.09, but 9 newtons, which is put in here, right? And that shall give us a velocity of 2.9439 meters per second squared. So now part 2 of this, which consists of us putting the equation that we have plus 1/2 acceleration times squared. X form is x0 xt, right? So do this by the y initial is 2m minus 0.6m, which gives us 0.4m, right? So we have y equals 1.4. Put the 1.4 there. Plus LT minus 1 squared, WT squared, and x is given to us 2.9439, right? It's time. So for the y component, do 5t, right? Is y 1.45t squared gives us 0.28 radicalized. So for the x portion we do 2.9439 times 0.28 as we had before. Now that gives us the x to be 1.5578 meters, which is the closest to our answer choice, which is 160. So here we'd have velocity being the square root of gm over r. So that's the area of gm over 2r, right? Which is equal to v over square root of 2. No, yeah, square root of 2 is easy.